the new set of PDFs for the lectures, but I really want you guys to install your own MariaDB instance and practice on these commands. So create your own tables. We have seen a lot of examples for tables. So for example, recreate this bank bank database in your system, and then play around with the select operations and the from and the wheres and all of those things. That would give you a better clarity as to what it is. Because homework number 2 would be solely for these SQL operations. Okay, let's see. Select customer name from this thing. Yes. By default, your SQL operations will eliminate all duplicate tuples, because set operations specifically in SQL are only going to operate as set operations. So that means it is going to output sets. But if we want, we can say that no, do the multi-set version of this thing. So I want to see duplicates in my results. So in that scenario, you can imagine that we want to count all possible bank accounts or all possible bank branches, even with duplicates for some reason. So in that particular scenario, you can say that select one, some select query, union all, select two, right? Or that same applies for intersect all and except all as well. Okay, so this would actually not remove your duplicates and give you all the things. Okay. Now, since we have been talking about multi-sets and sets, let's take a quick example. Let's say that we have two relations, R1 and R2. Both are multi-set relations. That means that there are duplicates here. And let's say that some tuple T appears C1 times in R1 and C2 times in R2, right? So T appears C1 times as duplicates in R1 and C2 times in some other relation R2. Does that make sense? So essentially we are saying that let's take some tuple, let's say A318 Los Angeles 550, right? So A318 Los Angeles 550 appears 10 times in one relation and 15 times in another relation, right? So if that is the case, if we perform R1 union R2 or R1 union all R2, first let's talk about R1 union R2, just union. Then if it is just a union operation, then how many times would the tuple T appear? 1 time, 0 times, C1 times, C2 times, what? If it is just the union operation, that is following set rules. One times, right? Does everyone agree with Justin? Because it is just the union operation and T appears in both R1 and R2. Once we perform the union, it would be just once, because it would remove all the duplicates. Now, if we perform R1 union all R2, then our union all operation would contain C1 plus C2 copies of T. Is this correct?
Yes.
Right, because it would basically contain all of the duplicates. Exactly. What about R1 intersect all R2? Intersect means that things that are common to both of them. So basically for that, we would get a minimum of C1 or C2, right? Whatever is the minimum, we will get the minimum number of duplicates, right? And we also have the except operation or the set difference. So R1 set difference all R2 or R1 except all R2. That would basically give you the minimum value for C1 minus C2, or if C2 has more values, then basically 0 copies of T. So if you go through this, this should make more sense to you guys, but essentially this all makes sense, but do go through this. Any questions?
I'm lost.
Essentially what I am asking is, if we perform the union operations, by default, the union operations will always be as set values, right? So if I perform the union operation on, let's say, the account and the low, right? I say select branch name from account. And remember, if I do select branch name from account, so if I perform select uh, branch name from account, right? What will I get? I will get
New York, Seattle, Los Angeles, and New York and Los
yes,
Angeles.
right? I would be getting these results because it's a SQL operation. So multi-sets are there. So essentially duplicates are allowed. Now, if I do the same thing, select branch name from, let's say, loan, what will I get?
San Francisco, Los Angeles, Las Vegas, and Seattle.
Seattle, right? Now, this is a stupid example.
The Union.
Yes, union, but give me a quick second. Let's say that I'm going to add a couple more. Let's say that we have another LA and another NY, just for the sake of it, right? Not exactly from this table, but just let's say that we have these values as well. Now, if we perform a union over these two values, so let's say select this thing. And select this thing, right? So this is the union operation. So essentially the result of this would be, well,
There will be two New Yorks.
no, since it's a union operation, since it's DBMS, then yes, it is multi-set. But since it's a set operation, union, difference, or except, or intersect, then it follows the set rules, right? So it would give me one New York for a New York, one Seattle for Seattle, one LA for all of the number of LAs that we have. So one LA, and what else do we have? That's all, right?
Las Vegas.
Well, we won't get Las Vegas. Oh, right, Las Vegas, because
Oh,
we are doing
yeah,
a
you're right.
union,
Never mind.
right?
Never mind.
Yes. Las Vegas,
San Francisco.
Las Vegas.
Basically, we have everything, but just gonna cut out on the duplicate.
Yes, it won't have the
Exactly.
duplicates. And I'm sure I missed someone, but you missed some of the things, but you can get New York, Seattle is the LA, NY, LA is the SF, LLB, Seattle, LA, yeah, right? So essentially, if I performed this operation, I would get this particular result. Right, so that is the union operation because it is still considered as a set operation, so it would remove all the duplicates. However, if I performed a union all, that means that I want all the duplicates, right? Give me all the duplicates. So that means it would essentially be the entire list here, followed by the entire list here. I don't care about duplicates. I don't care about the order, obviously. So get me all of the things, duplicates or no duplicates, right? So that is the difference between union and union all. So if we had a tuple that appears C1 times in R1 and C2 times in R2 with those two relations, we can say that if we perform a union all, then it would basically be the total number of copies in both of those relations, right? C1 plus C2. So essentially, we had New York twice here and once here. So essentially, in our result for union all, we would have New York thrice here.
Okay.
Right? So that was union all. Intersect all basically means that we are only going to show you the things that are common across both of those relations, right? So that means that if I have C1 copies here and C2 copies here, I would only give you the things that are common. So essentially, if I have two New Yorks here and one New York here, I would only get one New York because one New York is common across both. So that is what it says, minimum of C1 and C2 copies of T. And set difference, remember, is slightly more trickier because all of the values in R1 that are not in R2, right? So C1 minus C2. So all of the values in R1. So let's say there are 15 copies of T in R1 and 5 copies of T in R2. So we would just have 10 copies because all of the values in R1 that are not also in R2. Right. So 15 minus 5, I get 10 copies of T. However, if it was the other way around, 5 copies of T in R1 and 15 copies of T in R2. I'll show it. 5 copies of T in R1 and 15 copies of T in R2. Then that means that none of these things would come because 2 minus 5, all of those go away because all of those things are common here. So essentially, I would get 0 copies of T if R1 has lower number of tuples that are still are duplicates. So essentially, it would contain max of C1 minus C2, comma 0 copies of T. There are other ways of writing this, but I think this should work as well. But essentially, remember that we can convert our set operations into multi-set relations by just adding the keyword all to it. Okay, so that was the basic thing that we studied. Any questions?
Can you show it in the notepad to the -1?
The -1? Okay.
Yeah.
Let's say that let's say minus was except, right?
Oh, okay.
So minus is except all because that is the set difference, right? So except all basically means, let's say that we have this except this. So let's first do just an except, right? So that means that all of the things here that are also not here. So New York,
Okay.
does not come here. Seattle, nope. LA, nope. New York, nope. LA, nope. So it gets nothing.
There's SF though, right?
Yes, but SF is on the right hand side.
Oh, okay.
Remember what was the diagram for a set difference, right? So let's say this was R1. Let's say this was R1. And let's say this was R2, right? So all of the things in R1 that are not also in R2. So we remove everything that are not in R2. So just this part. So
Okay.
things that are unique to R1. And it changes if I change what R2 and R1, where they are, right? R1 minus R2 is not the same as R2 minus R1.
Oh, okay.
Right? R2 minus R1 is this green bit here,
Okay.
right? Not that red bit, right? Okay. So if I do select branch name from account, we get these branches, except select branch name from loan, which are these branches. So all of the branches here have a copy here. So nothing comes up. However, if we did it the other way around, let's say that we did next. So select branch name from loan, those are these accounts or these branches, except branches from account, those are these branches. So essentially what is this saying? Give me all the branch names which have a loan but don't have an account.
Oh, okay.
That is what this says, right? So essentially if we now check SF, well, SF does not exist here. Well, SF is 1.